Hello students, and welcome to another how-to video on writing chemical equations of combination reactions. And here we have two examples. They're found in your packet, so if you want to follow along there you can, or if you're on a separate piece of paper and practicing, you can do that. So here we have it in chemical formula, and then here we have a story problem that we're going to write out down below. So in this first reaction we have antimony combining with iodine to form antimony triiodide. And first thing we notice here is antimony is balanced on both sides, while iodine has 2 and 3 respectively. So in this problem, we've got to figure out how to get these iodines to balance, because they're the ones that are causing the problem here. And iodine, as a reminder, is a diatomic molecule. Okay, it does exist on this row from fluorine down to iodine. You can see that there. Okay. Iodine is diatomic when it's by itself. Okay, and when we do this, this may take a little bit of effort to think about this, but what we need to do is find the common denominator between 2 and 3, okay? Because it's a little challenging. If this was 4, all we could do is just double it and then move on, but you can't just double the 2 and make it equal to 4. We've got to find a common denominator. So what we're going to do is we're going to take 2 times 3, and our common denominator is 6, okay? In order for 2 to become like 6, what we're going to do is we're going to make it 3. And over here we have 3, and we're going to make it 2. And let me explain and break it down for you. Now we have 6 iodines on this side, and now we have 6 iodines on this side. You see what we just did there? Essentially, I just switched it. So I'm going to times this side by 3 and this side by 2 in order to get to that common denominator. So now my iodines are balanced because I now have 6 iodines and 6 iodines. It balances out, okay? And my antimony is no longer balanced because now I have 2, so on this side I add 2. And that's a happy equation. Now it's balanced because 2 antimonies and 6 iodines on either side, okay? So always start with always work with the ones that you know that are balanced, okay? Those are the ones that you know we don't have to work with. Start working with the ones that are different from each other, and then you start working backwards to the ones that you originally were noticing that were matching, okay? Now down below we have hydrogen and nitrogen, and they're going to form ammonia gas, okay? And I even left a note here that H and N are diatomic, okay? So let's do this. We have H2 plus N2, form an arrow, and we have NH3, and these are all gases. Okay, and it's a combination reaction because we have 2 substances that are combining to form one new thing. And we notice is nitrogen 2 and 1, and then hydrogen's 2 and 3. So these are both not going to line up with what's over here. So we have to start with one of these. And typically I like to go with hydrogen second. So nitrogen is going to be the one we start with. So if you have 2 here, come over here and add a 2. So now our nitrogens are satisfied. They check out. And our hydrogens, we have 3, but we have 2 of this molecule. If you can imagine, this coefficient is talking about the whole. So it's 2 times 3 of these hydrogens, so there's 6 hydrogens. And in order to have 6 hydrogens on this side, I have to have 3 hydrogen molecules. So if I were to write this out again, it'd be 3H2, it'd be a gas, plus N2, gas, is equal to 2NH3, it's a gas. Okay, so that's now a balanced equation. We have 6 and 6 hydrogens, 2 nitrogens and 2 nitrogens, okay? Thanks for watching.